welcome everybody. For those of you that are new here to campus, welcome. I'm just going to give a little overview of who we are and what we do. So we're the Chesapeake Biological Laboratory. We were founded in 1925 by Reginald Truitt. So for those of you that you can do math, we're coming up for our 100-year celebration next year, so we're really excited about that. So stay tuned, look at social media, we'll have some events coming up. In addition to our annual open house, which will be on September 6th. So we are the oldest state-supported marine lab on the East Coast, and we're one of 6 constituent members of the University of Maryland Center for Environmental Science.
Share your screen.
That would help. Thank you, Tom.
You're welcome.
Okay. Okay. All right, we'll try this for the 3rd time. So we are a university, and we're part of the University System of Maryland, and we have 6 different laboratories across the state of Maryland, from the Appalachian Lab in Frostburg, Horn Point Lab in Cambridge, the Institute of Marine Environmental Technology in Baltimore, and also we're joined with Maryland Sea Grant at College Park, the Integration and Application Network. Is that work? Thank you. And so this is we're partners, 6-partner institution. And as I said, we've been here for 100 years, and we are not just renowned locally and nationally, but globally. We're a leader in the science of coastal environments and in their watersheds, and also in graduate education. So for those of you that are local here, one thing we're known for is our focus on long-term data sets. Back in 100 years ago, Reginald Truitt recognized the importance of water quality and controlling ecosystem health, and started measuring things like temperature and salinity. And we've gone on to expand that. My colleagues here have the Pentuxent Centennial website. So I provided QR codes here, but there's actually a handout of QR codes that I'm talking about. So you can take pictures, but there's actually a handout if you want to take those at the end of the night. So you can see from this picture, I use this site regularly. This is how I get to work in the morning and how I leave in the evening. And we've seen last month, for 2 weeks, there was flooding by the Tiki Bar, and so much so that I had to do the alternate route. But this is a really nice site if you want to have any idea on what sea level the flooding is by the Tiki Bar, or what the salinity, the temperature of any of you, and for those of you that are in St. Mary's, if you want projects, this is good for a senior thesis. All of our data is downloadable, and you can do all sorts of analyses with it. We also are engaged in our community. I mean, it's our community that started this lab 100 years ago, and you've just driven past and have probably seen this. This is our Solomon's Climate. This is actually the data that's collected from the pier, that long-term data set. This is the water temperature over that 83-year period. And, I don't have to say much about this, but you can see that the blue is cooler, and the orange is warmer, and it's showing that trend to warmer waters in recent decades. The other thing we're really passionate about here is our Dolphin Watch program. Again, this is a community-led program. We rely on you all. And again, I know you're all going to have seen dolphins in the bay. How many? Yeah, and how many have got the app? And if you don't, we have the QR code. So if you're out on the water, walking along the boardwalk, you see a dolphin, take a picture, send it to us. Your data actually helps us with the science on understanding where the dolphins are. We see them now all the way up to past Baltimore, and how many we're seeing. We're seeing them also coming in at earlier times of the year as well. So this is a really nice community-led project, and we really welcome you joining us in that. You also might have seen the structure on the right-hand side. That is our new building that's coming up on campus. It's our Chesapeake Analytics Collaborative building. It's a $22 million investment from the state of Maryland. It's going to house a lot of meeting spaces, high-end AV equipment. It's going to allow us to bring a lot of people, the number of people that we need from all different walks of life, from industry, from the local communities, to NGOs, to scientists, bringing people together to address some of our complicated environmental problems that we're seeing, constantly now, and to try to provide actionable solutions to fix them. So just finally, as I mentioned, we are leaders in environmental education. We have a very innovative graduate curriculum. Some of our students are at the back here, very interdisciplinary foundations. And the goal is to solve real world problems. It's very applied research. And it's not just solving problems here locally, nationally, but also globally. And this is my plug as the interim director here is, please donate to our students, keep their research programs going. It'd be very much appreciated. That's what the handout on the QR code on the chairs will get you to. So thank you for that. And so after that brief introduction of who we are and what we do, I would like to introduce Jessica McGlinsey. Jessica is our turtle guru, and these are our little babies. And so please, at the end of the talk, feel free to come up and see them again. And I really thought those eggs were real. I cannot believe her son 3D printed those eggs. I was expecting those things to hatch. Again, she is a PhD student working on the Diamondback Terrapins. She's a graduate student in the laboratory of Dr. Christopher Rao, who is a herpetologist here. And they are also focusing on long-term data sets. This is the long-term data set that they have looking at the populations of terrapins. I don't want to give the game away, but the population of terrapins that are at the Patuxent Naval Air Station, which is a really important site for diamondback terrapins nesting and reproduction. She is also a fantastic project coordinator for our Wave of Plastic program. So for any of you that have children in the either in the St. Mary's or Calvert middle school systems, this has been in the school systems as part of their curriculum for the last 6 years. It's called Wave of Plastic. If anybody homeschools or is interested, it's all available online. All of our units and our curricula and videos is available online. And it's also a great thing for upcoming, school, middle, elementary, high school projects as well. So take a look at that. The QR code for that project is also out in the hallway. So as I mentioned, Jessica works on the iconic Maryland Diamondback Terrapin and specifically focuses on implications of climate change and shoreline erosion to those populations. So I know let's focus on Jessica. I know it's very easy to focus on these little guys up here, but again, after the talk, you're welcome to come up and see these. So with that, I'll hand over to you, Jessica. Thank you.
Thank you. Thanks, Chris. All right, thank you everyone for being here today. Can everyone hear me okay? Great, thank you. All right, so my name is Jessica McGlinsey. Thank you for the introduction. Tonight, you guys were going to hear me say "the" and "our" a lot, and that's because this research isn't my research. With most things science, there's collaboration, there's partnerships, there's teamwork. So I'm going to be referring to everything in the "we" or "our," and that just goes to speak volumes to all of our partners in this research. What I'm going to be showcasing tonight is a diamondback terrapin in a changing climate. So I always include this side. I do a lot of teaching as well. I teach at St. Mary's College and CSM. So for our students who are in the audience, or for any of our young professionals who may be watching, this is just a path to how I got to where I am today. So if you're wondering what organizations may be useful, if you're finding yourself interested in the same path, I like to share this slide just as a visual. And I like to share the information at the bottom from Doug Talamy. Knowledge generates interest, and interest generates compassion. And I like to add a piece to that says compassion generates action. And that's what this is all about. We're sharing knowledge, we're gaining compassion, but we're aiming towards action. And that's actually one of the University of Maryland's new initiatives. It's impact to action. So the research focus is within the Chesapeake Bay, and we're focusing on the Northern Diamondback Terrapin. But I'd like to start by introducing you to the Diamondback Terrapin. So I could talk about the terrapin itself for hours, as could I multiple of these topics. So you're going to get a brief overview of a lot of these topics, but piece them together so you understand how they're related and what we can do to help the terrapins. So the terrapin is Maryland's state reptile. And for those of you who go to the University of Maryland, go Terps. It's the University of Maryland's mascot. The terrapins are the only estuarine endemic turtle in North America. And what that means is they live in the brackish marshes. They do not go to the open oceans. They do not go to freshwater ponds. They are only found in the brackish marshes of the Chesapeake Bay. Their native species are found in the marshlands from North Carolina to New England, and then do not typically travel in the open oceans. So as we start to talk about the implications they're seeing in their habitat, keep that in your mind. If they can't travel to the open oceans, where can they go if their habitats are threatened? And that's what this is all about, because we are the ones that are here to help them. They spend most of their life in the water. However, they leave the water to bask and lay eggs. They feed mostly on invertebrates like snails, mussels, or clams. If anyone's ever seen those marsh periwinkles that climb up and down the seagrasses, those are one of their favorites. They're long-lived, over 40 years, late to mature, females 6 to 12 years old, around 7 years old. They average 4 to 9 inches in length. Think of a small size paper plate versus a medium to large size paper plate. The females are larger, almost the size of a composition notebook, if you were to find a larger female, weighing anywhere from ½ a pound to 4 pounds. And they're much stronger than I had ever imagined. The first time I picked up a terrapin out in the field, they're able to kick your arms to try to get away, and they are very powerful. Rightfully so, they have to dig through some tough substrate to get their nests laid. Their nesting season in Maryland runs late May through August, and females nest 1 to 3 times per season, laying 6 to 20 eggs, typically 12, each time they lay a nest. We've seen some as low as 5, some as high as 15, so 12 is about the average that we expect to find. They are IUCN listed as a vulnerable species across its range. We're going to come back to this in a few slides because some of you may know what this means and some of you might not, so I'd like to show you what that means. Their threats include predators, pollution, road and boat traffic, harvest, bycatch, habitat loss, and climate change. And then let me introduce you to the Chesapeake Bay and our research area. The reason why I'm sharing a picture of the whole watershed is when we think about ways to protect the terrapins and how our actions have impacts or implications, it's important to understand that anywhere someone lives within this watershed, so tell your friends, tell your relatives, if you live anywhere within the watershed of the Chesapeake Bay, the choices that you make in your home can impact the species that live within the Chesapeake Bay. Our research site is located where the Patuxent River meets the Chesapeake Bay, right outside here. For those of you that are here, if you step out from the lab and look across the river, while it's dark now, if you can look across and see where the Naval Research Center is, that's where our site is. I can see where I sit in the mornings over the summer from the edge of the creek here. So to dive in a little bit deeper, this is our research site. It's a 0.3-mile shoreline right over where the Patuxent meets the Chesapeake Bay. Now, for those of you in the room, you can see my mouse here, but when we travel to our research site, we're actually traveling within the forest area out to the end and back. So our walk in the morning usually ends up being about a mile. We're not walking just the shoreline, we're walking in the forest. And does anybody have an idea why we don't just walk the shoreline? Why would we be walking within the forest area? Does anybody want to take a guess?
Because there's snakes.
It's okay, go ahead. There might be snakes in there, but we're looking for one thing while we're out there in the morning. What do you think we're looking for? Let me give you a hint. Turtles, turtles. The female terrapins will come ashore and go into the forest as well, not just the shoreline, because their shoreline is eroding and they're losing habitat. So we're finding them in the forest as well. So what I'd like for you to do is keep an eye on this yellow line. This is from Google Earth. Google Earth updated, this is only 2022. So keep that in mind as we're looking ahead. We know there's 2 years worth of difference that's happened already between this here. And I'm going to show you a time lapse over the last 20 years through Google Earth of what's happened already at this research site. So here we are at 2003, so 20 years ago. So as you can see, just over the last 20 years, we've lost quite a bit of shoreline out here. This is a very dynamic ecosystem. There's wave energy from the Patuxent River meeting wave energy from the Chesapeake Bay. When storms get pushed ashore, all of that energy comes here to this location. So we knew that it was time to start gathering data and figuring out what's actually affecting them, but most importantly, how can we help them? So when we're out there looking for the terrapins, we're out typically June through August, and the incubation of their nests takes around 50 to 55 days. Can be longer if it's cooler, shorter if it's hotter. And hatchlings emerge late July through September. But the nests are found anywhere above sea level, in the cliffs, on the beach, at the edge of the marsh, and even in the forest. The picture on the top left here doesn't really do it justice, but that nest is halfway up a cliff, about 3 feet up off the ground. So that mama sea turtle was doing a handstand, laying a nest on a cliff 3 feet off the ground. And to me, that's just fascinating. So they're finding the space that they can to lay their eggs as safely as they can. The picture on the bottom right is a mama that I was able to grab while she was laying her eggs. We always take moms back to where we found them. If they come and help us in the lab, we take them right back to where we found them. The two pictures here on the left, we got lucky that morning. And these are pretty clear pictures that you know somebody walked on shore from the water. The picture on the bottom shows the turtle shell scraping along the sand with the tail and their 2 feet on the side. And the picture on top shows 2 feet. They were standing up a little bit higher on the top picture, so there's no shell. So if you were going on the beach with me looking for turtles, this is one thing we would look for, but this is pretty easy to see. It's not always like that out there when we're looking for the terrapins. The moms can spend an hour offshore or a few hours offshore surveying the area to decide when it's safe to come ashore. We go out June through August and we sit out there every morning before sunrise, watching for moms. We hide behind the Phragmites, although we don't like Phragmites because it's invasive. It's a great hiding place. So we hide behind the Phragmites so they don't see us, and we wait for them to come ashore. And we can watch the same mom for 3 hours. Come ashore, change her mind, and go back. And it's this ebb and flow. They can see things as small as a sandpiper walking across the beach, and it scares them. They know there's predators out there, so they're waiting until it's safe. When they finally decide it's safe, they'll scurry ashore, find their space, and then it can take them up to an hour to dig the nest, lay the eggs, bury the nest, and then run back out to sea. The nests are typically 4 to 12 inches deep, usually around 6 inches, and each nest again will have an average of 12, depending on how fit the mother is and how safe she feels. If the mother feels threatened, they will stop what they're doing. So even if they've only laid 1 or 2 eggs, they'll stop what they're doing and go back out to sea. Now, some of them will stay and try to finish. We have a few moms that continue to come back who have injuries to their feet. And those injuries occurred while they were nesting. They were trying to finish nesting and bury their eggs to keep them safe, so they have injuries to their feet. So I'm going to show you a picture on the next slide, and you guys get to be turtle detectives. Are you ready? Okay. There is a terrapin nest in this picture somewhere. I'll give you guys a few seconds to look at this. This is more like what we encounter out there in the morning. No turtle tracks, no flat sandy beach. There's a lot of gravel and pebbles on the top of one of their favorite nesting sites. And this is literally what it looks like out there every morning, trying to determine where their nests are. And the reason why we're looking for their nest is because we have to help protect the nest. This cage that I brought with me today is one of the cages we take out in the field. Once we locate the nest, we put loggers in the nest to measure the temperature, the moisture, and the sun, and then we cover it with the cage to keep it safe from predators all nesting season. Anybody think they found the terrapins? Give me a thumbs up if you think you might know where they are. Are you ready?
Right there.
Right there, right there. That was the terrapin nest. So this is just a perfect example of what our mornings are like out there trying to find these terrapin nests. I wish it was as easy as following tracks like this every morning. Those are turtle tracks, yep. So this is what the site looks like midway to the end of the season. There are cages everywhere, and those signify nests that we're keeping safe. So those are about 12 terrapin eggs in each of those crates, staying safe throughout the season, that are going to have a chance to enter the marsh and grow into happy, healthy baby turtles. This graph here shows the successful nests at Pax River Naval Air Station. So when I was talking about the partnerships and the people that are part of this project, this data started in 2013. So again, 10 years worth of data showing us an upward trajectory of the successful nests that we've been seeing at Pax River. And this is in part thanks to the partners at Pax in the Navy. They have interns that come from the SCA, Student Conservation Association, CSM, SMCPS. So there are multiple people out there and other volunteers who aren't in school. They have adult volunteers, younger volunteers that come and join. So it really is a group effort. There are people out there morning, noon, and night looking for these terrapin nests so we can keep them as safe as we can. When you see anomalies like the year 2016, where we see a sharp drop in data, that could be that year had a lower nesting population, but it could also be that there was an anomaly in the volunteers, in the protocol, in the gear. So if anyone ever gets involved in monitoring efforts, it's very important to remember that even though it's a volunteer experience, the protocols are in place to follow during monitoring because this data is used for science. So we have to make sure the data we're collecting is accurate so that graphs like this really show an accurate picture of what's happening out there. And as you'll notice in quite a few of these pictures, you're going to start to see a theme. There's a lot of fallen trees, and that's at the shoreline from the erosion. So you'll notice that as we go through these pictures. And these successful nests lead to baby turtles. So for those of you here in the room, I brought some of the babies here for you to come see today. For those online, I have some videos to share. Don't worry, you're still going to get to see some babies. So as you can see, from 2013 to 2023, again, the trajectory of successful nests is on an upward path. Starting with a low number of nests, again, could be just because we hadn't learned how to find them. As we perfected I won't say perfected, as we practiced the techniques about how to find these turtles, the nest numbers are going up, but they could have been there all along. It's that we're able to find them now, and we know how to protect them. So our nests are getting more and more successful, leading to more and more successful hatchings. So some of you may be asking, well, why are we studying the Chesapeake Bay and the terrapins? Before I dive into anything further, I wanted to come to this slide to talk to you a little bit more about why we're studying the terrapins in the Chesapeake Bay. So the IUCN has a red list categories. There's extinct, there's threatened categories, and there's least concerned. Again, when you're at the least concerned, that is the lowest of their categories, working your way up to extinct. The terrapins are listed as a vulnerable species, which is within the threatened category. So when you're talking about species, that means they are red listed, which means they're in danger. Vulnerable species are facing a high risk of extinction in the wild. So that right there tells us they need our help. But the IUCN also thought, we're studying species, we're red listing species, but we need to focus on the ecosystems these species live in. We can't save the species if we don't save their spaces. So they've now started the red list of ecosystems. And as you can see here on the bottom left, do you see what the Chesapeake Bay is rated? Chesapeake Bay is rated critically endangered. So critically endangered is facing extreme risk of extinction or for the ecosystem collapse. So again, these two pieces put together really show us that not only do we need to understand the terrapins, we need to understand the space that they're living in. And that's where a lot of my climate change focus has come in, because that's a big part of what's impacting the Chesapeake Bay today. So threats to the terrapin, there's multiple threats. Again, we could spend hours talking about each one of these. So harvest or accidental bycatch. If anyone's ever seen anyone with a crab pot, you've probably seen those orange excluders. They're called bycatch reduction devices, or some people call them turtle excluder devices. So what that means is the turtle cannot get into the crab pot, but the crab still can. And they've actually found if fishermen use these reliably, their crab catch is actually higher because there's more room in the crab pots for the crabs, not the terrapins that accidentally got in. And the problem with that is once the terrapins get in, they can't figure out how to get out. And the crab pots are underwater and the terrapins cannot hold their breath that long. They're also facing predators, which is again why we are covering the nest with cages to help protect them, and road traffic. So especially around here during the summer season, slow down for turtles. And always, if you help a turtle, which side of the road should you take it to? The way it's going. Take it over to the way it was going. Yep. So we are going to focus on climate change and habitat loss. And Dr. Mitchell-Moore showed you this picture earlier. This is without definition. This shows us how the climate is changing, whether we're talking about air temperature or water temperature. And this picture down here is another picture of erosion at the site we're working at. So this is a brief overview of climate change. And the two pieces that I'm going to focus on is global temperature rising and global sea level rising. So at the start of the Industrial Revolution, we really saw an increase in carbon dioxide, and these emissions impacted the temperature. We started to see a global rise, a gradual rise in temperature. And then around the 1900s, when we added more people needing more spaces, we started deforestation, and we also started having higher fossil fuel usage just because there were more of us here using those fossil fuels. We started to see an acceleration in the global temperature. One thing I like to point out, if this graph were to continue, you can see how there's a pattern to it. This beautiful up and down, almost like the heartbeat of Earth. And I do say, when people share, the climate has always changed. Earth has always changed. You're right, it has. It's been on a beautiful rhythm of warming, cooling. But what do you see at the end of this graph? A very high spike that's not within the norm of what we've seen. And that's what the problem is. The problem is the rate of change. Our choices and impacts have drastically changed the temperature from where that natural pattern was taking it. And the same thing for sea level. If you look over at the graph on the left, sea level is also increasing. And that is from a few factors we'll talk about. But first, we're going to talk about the temperature increase and its effect on terrapins. Our research is multifaceted out here at the Patuxent River. So annually, since 2018, we have monitored the temperature of natural nests at the Patuxent River Naval Air Station. This data set in this map is from 2021, just showing the fluctuations in temperatures. And in cooperation with the Naval Resources Conservation Program, protecting the diamondback terrapin nests from predators, we deploy data loggers in nests at the time of nesting. So when we're out there looking for the moms coming ashore, we let the moms lay their nests, and then we come right behind them because we know where they are. We didn't lose them. We knew right where they were. Up here on the table, I have one of the loggers if you want to come take a look at it. So we will uncover the eggs, count the eggs, weigh them, measure them, put the loggers in, bury the eggs back up, and put the cage on top to keep them safe. And those loggers are collecting temperature, soil, moisture, and air and surface temperature records, 15-minute intervals throughout the entire nesting season. So it gives us a picture as to what the terrapin eggs are experiencing in their nests. But why do we need to know all this? How will the rise in temperature affect terrapins? The warmer the temperature, the more females we'll see. And as we just talked about, the global temperature is increasing. So we know at some point we will get to a temperature where the nests produce mostly or all females. And that's going to drastically impact the species' reproductive success. Terrapins do not have chromosomes that determine if they develop as male or female. The temperature for the terrapins during nesting is what determines that. The nest temperature during a brief portion known as the thermally sensitive period. So if we think of this 50 to 55 day period, let's use 50 just because the math is easier. We go to day 25 right there in the middle, usually a 1 week, 1.5 week time frame, maybe 2 weeks, depending on how long their nesting season is. That period in the middle is their thermally sensitive period. It doesn't matter what the temperature was before or after that. It matters during that middle time frame what the temperature was within the nest. If the temperature is higher, it'll produce more females. If the temperature is lower, it'll produce more males. Right now, the temperature is thought to be about 84.7 degrees Fahrenheit or 29.3 degrees Celsius. We are working to try to determine if that number is accurate and if we need to move that number higher or lower. And the reason why this is important, not just for terrapin conservation, but every species that's temperature dependent. The more we can understand about how to gather this data helps us know how to protect the species, because we'll know at what temperature these nests will be all females. So then we'll either have to intervene with raising some in a lab or in a conservation facility where they can be raised male, or putting shade structures over known nesting sites to help lower the temperatures. Using the data from 2018 to 2020, so this is actual data from the field. If we use that data with this 84.7 degree temperature, 61% of the nest would have been female biased, meaning more females, and 58% would have been all females. So let's think about the global temperature change. We hear them talking about 2 degrees Celsius is the mark we're trying to stay away from, but we know we're quickly approaching that. With an increase of 2 degrees Celsius in the temperature of the air temperature, the nest temperature, 91% would have been female biased and 82% would have produced only females. So again, with just that 2%, we are getting very close to a point where not many males are being born. So I'd like to take you along and show you some pictures from research. This is in the field. So this was me gathering some of the eggs in one of the nests. We take all the eggs out, we weigh them, we measure them, we put them back in safely, and we put the cage over top and put our loggers in. And this is done throughout the whole nesting season. So we aim to have at least 10 of our own caged nests out there, and the Navy usually sees around 100 or more. The site is very active. To put that into perspective, I did some volunteer work with another organization working on a terrapin project. I thought, great, I've done this, I know what we're doing. And I had my experience from this site to take with me. And at that site, they were very excited to talk about the 3 terrapin nests they usually find every summer. We celebrated that with them. That's huge for them. They're able to find 3 every summer at this small beach that they have. But for me, that was really humbling. That really put that into perspective, just how important this site is if we're seeing over 100 nests every year. So we also do lab work. We bring some of those baby turtles back with us to the lab, and we do incubation studies, meaning we have 2 sets of data we're gathering at one time. We have the loggers in the field, so we're learning what's happening in nature. We're letting nature take its course, seeing what the temperature data is, but we're bringing them back to the lab where we can dictate what the temperature is, starting at a cooler temperature, a warmer temperature, and working our way towards the middle. Again, trying to find that pivotal temperature, trying to see when we have all males, when we have all females. And in the name of conservation, we are trying to find a safe way to tell if these are male or female babies, because when they're this small, you can't tell by visually looking at them if they're male or female. So we're working with some organizations to try to develop a blood test. And that's what all of these little vials are. You can see my fingers. So you can see how tiny these sample tubes are and how tiny these blood samples are. So we don't have any results from this. This is still something in process, but we're trying to develop this so that others can do the same thing. Take a tiny blood sample, tell who's male or female, and then we can relate that to the temperature they were incubated at. And we're also now practicing husbandry. So because the blood studies were taking a while to figure out, we thought, hey, let's raise some in the lab for a year or 2. Once they get about this size, we'll be able to tell who's male or female by visually seeing. Because remember, females are much larger than males, so we'll be able to see the differences within their bodies. And for those of you online, here is a video of some of our babies. So, and don't worry, these guys are happy, healthy, well-fed, they're warm, they're growing fast. And in fact, terrapins in the wild, the hatchlings only have about an 8% chance of surviving their first year. So these guys here with us have a 100% chance of surviving their first year. We have about 70 to 80 of them that we're raising for the next year or 2. And they're just adorable. All right, so to couple that, we're gonna hop over to sea level rise and how that's affecting the terrapins, because both of these are happening at this same place. So not only are the terrapins facing the temperature increase and what that's doing to their offspring and their reproductive success, but they are facing sea level rise, erosion, and habitat loss. So sea level rise in the Mid-Atlantic region has been 3 to 4 times faster than global average over the past 25 years. And that's for many reasons. When we think about sea level rise, we think about ice melting and how adding that water is raising the sea level. When the ocean absorbs heat, it expands, again, raising the sea level. But here in the Mid-Atlantic region, we have an interesting combination of effects happening. So during the last ice age, the ice sheet came right to the edge of Maryland. That ice pushed down all of that land, which made Maryland bulge up. Picture if you had a balloon in your hand, which I did not have balloons at home because I was going to bring one to show. If you had a balloon in your hand and you squeeze one side of the balloon, the other side gets bigger. The exact same thing happens when glaciers are sitting on land. They compress the land on one side and make the other side rise up. Well, now that the glaciers retreated and melted, the land is naturally rebounding, but that means we are slowly sinking. So it's making the effects of climate change seem even more drastic here in the Mid-Atlantic region. In addition to that, the aquifers under our feet, we are draining those at a higher rate than they can refill. So the land is also subsiding because of the draining of the aquifers. Excuse me. And in the Mid-Atlantic region, we also know all of that storm surge is pushing that energy, that water energy inwards, which that was what Dr. Mitchell Moore was referencing. Those 2 weeks where the island was flooding here, that was storms and waves offshore, the winds offshore, pushing all of that water inland, just exacerbating the sea level rise effects. So these are some definitions for those who might not be familiar with climate change. These are really important aspects to understand about how climate change is affecting our Mid-Atlantic region because we have such a unique experience happening here. We have the ice melting, thermal expansion, land subsidence, remember the rebounding from the glaciers melting, and the aquifer and the groundwater collapse. And as you can see from this graph, just over the last 46 years, so from 1975 to 2021, we've seen an increase in sea level in Annapolis, Baltimore, Solomons, and Cambridge. And just like the other maps that were on an upward trajectory, unfortunately, these are too. And the Chesapeake Bay has a lot of low-lying habitats. The blue and 2 shades of green are less than 1 meter in elevation and likely to be submerged by 2100. So this is just a visual of the Chesapeake Bay, what that means for the coastlines of the Chesapeake Bay. And the yellow, 1 to 1.5 meters, so submerged or frequently flooded by 2021. Now thinking of this in a bigger picture of the Chesapeake Bay, if we bring that back down and we look at the projections for Baltimore again, 2020 to 2050, 15 inches, 2020 to 2100, 2020 to 2150. Again, these are projections. There are a lot of variables that can change between now and then. We could reduce our emissions drastically and be on one of these lower levels of projections. We could work on reducing the emissions and cleaning up the atmosphere with carbon sequestration. A lot of variables at play depending on where we'll be here with sea level rise. But here back at our site, how will sea level rise affect the terrapins? Now I want to point out something here that I actually just figured out making this PowerPoint. Do you see how some of those dots look like they're in the water? So this data is from 2023 to 2016. Anybody have an idea why those dots look like they're in the water? Say it one more time.
They weren't.
They weren't in the water. When this data was collected back in 2013, that's where the beach was. So I use GIS to do a simulation of what sea level rise is going to do with the habitat here. This is our baseline. And this is with 1 foot of mean high water mark sea level rise, approximately the year 2050. And this is with 3 feet high water mark sea level rise around the year 2100. So again, just drastically showing us that this site is in jeopardy if we don't work to protect it and help the terrapins. So sea level inundation and loss of habitat. All of these pictures here are from the site right across the river. It's a beautiful place. The terrapins love coming here. We see them every season, and this is full of the cages by the time the season is over because they know this is a safe place to come and nest. But all of this habitat is at risk of being lost either from erosion or sea level inundation. The graph here just shows, based on those pictures we saw previously, at the 1 foot mark and 3 foot mark, just how many nests would be inundated. The blue is the inundation. So again, at 3 foot, it's about half of them or not more. So erosion and loss of habitat. If you look at the picture on the top left from 2023, you can see the little lookout behind the little blind with all the trees around it. And the picture below it's from 2024. All of those trees are gone. All of that shoreline eroded in just 1 year. So all of the trees were gone from that site. The picture in the middle, the perspective's a little bit off, but the first one is from 2023. And if you picture yourself in the middle of that picture, there is a sandy path. Do you see a sandy path along the edge? The picture on the left is from 1 year later. Do you see the beginning of that path? And the entire path is gone. That tree is downhill. I actually couldn't walk as close to that tree. We lost 4 feet in just 1 season from that cliff right there. So why again is this site important? It's the conservation that's happening at this site. Let's average 75 nests per year, 12 eggs per nest. That's 900 hatchlings per year. So let's multiply that over the 10 years we've been studying this site and trying to protect the terrapins. That's 9,000 hatchlings that were given a chance of survival that wouldn't have otherwise had that chance. And when we were gathering one of the nests from the site to bring to the lab, this baby hatched while we were getting them out of their nest. So just like with the moms, any of the babies that come back to the lab to help us with a blood sample, we take them right back to where mom intended them to be. And that's what the top left picture is here. We do a hatchling release every year. We take the hatchlings back, set them back in the marsh so that they can grow up right where mom intended them to be. But our response to sea level rise is exacerbating the situation. Shoreline alterations prevent females from coming ashore. 80% of the Chesapeake Bay shoreline has already been altered from its natural state. And projections for the future extend to protected shorelines in Maryland. Again, these colors will show you the red is likely to be protected. The brown color is almost certain to be protected. And you can see just how much of the shoreline in the Chesapeake Bay region is going to need to be protected. So the question begs to ask, if the terrapins need access to the shore, are these solutions in these pictures the right way to go? As we learn more from this research, we're learning just how to protect our shoreline and protect the species that depend on it. So this picture right here is a typical shoreline protection. You'll see a straight rock wall. So the questions that get asked when companies are gathered to protect a shoreline is, well, first, will it protect the shore? Sure. That rock wall is going to protect the shore. It's going to protect it from the wave action, which is going to reduce the erosion and also help reduce the sea level rise impacts. Well, what have we usually done? This is what we've usually done. We know this works. How much will it cost? This is usually pretty cost effective. Are there companies that know how to do this? Yeah, we've done this for decades now. Can we get permits for this? Yeah, this one's easy to permit. The questions we should be asking: how will the terrapins access the shore? And how can we protect the shoreline and the species access to the shore? I was actually talking about this with someone earlier today, and they were mentioning that they do research on horseshoe crabs. And they can absolutely see how on shoreline restoration projects, there's multiple species that should be studied to see how they respond to these shoreline restoration projects. So questions that we're going to be researching: How will living shorelines protect the shore from erosion and loss of habitat? How will the terrapins respond? Will we see a reduction in the nest numbers? Will we see a change in behavior? And can we protect both the shore and the species? So how can we protect the shore and species access? Nature-based solutions. So you'll see this chart here going from green to gray. Gray infrastructure just means rock concrete, so they're gray, hence the name gray infrastructure. The more we can make our way to green infrastructure or living shorelines, green again from the plants and the nature that are used in the protection of these shorelines, the more likely we are to accomplish our goals, where we're protecting the shore, but also protecting the species that rely on the shore. This would be the best of all worlds right here. Instead of using any rock structure, you can use oyster bags. Oyster shells are great at breaking up wave action. They sequester carbon, they sequester nitrogen. Oysters filter the water, and they're protecting the shore from that wave action and creating new habitat behind them. Maryland now has the Living Shoreline Protection Act. It was passed in 2008, which mandates that shoreline protection measures be prioritized for non-structural solutions, such as these living shorelines, to control erosion. The law requires property owners to use natural stabilization methods like marsh creation and planting. I'll say with one caveat. If the proposed shoreline protection that is nature-based is deemed to not be as effective as the typical gray infrastructure, often gray infrastructure is still permitted and still put in place. So as community members with voices, that's something to think about when you're interacting with people who are making these regulations, who are doing these projects. How do you want to see your shoreline protected? And just so happens, right out here at the Patuxent River Naval Air Station, the research site for the terrapins has a $6 million shoreline restoration project that has started already. Now I'll say started already, but it started on paperwork. It hasn't started in the field yet. So those research questions I told you we're asking, we are going to start asking those soon. They plan to start the actual construction out at this site over the winter, hoping to be done before next nesting season. So the shoreline will look drastically different. And I want to know, how will the terrapins respond? Will they find their way to the shore where they've come for year after year and they know they're safe? Will we see a reduction in nest numbers, or will the nest numbers stay relatively the same? This project is a living shoreline restoration project, redesigned, permitted, and constructed for the reaches along the Patuxent River. Now, this one was redesigned because as the beginning phases of design started, it looked like this. Knowing the research that's been happening there for 10 years, someone stopped and said, wait a minute, we can't do this out there. How will the terrapins get ashore? So this site is unique in that the people working to design and implement this project have put what they've called windows into that rock wall. So there are, I don't know the exact measurements, but 4 to 6 feet openings in the rock wall to allow terrapins access to the shore. So having gaps in the rock wall will reduce the shoreline protection because some wave action can get through, but by how much? We don't know. These are all questions we aim to answer. Are we protecting the shore this way? And are the terrapins still making it to shore? So this site is really unique. This has been designed with the terrapins in mind. So if our research can prove that this is effective, then it leads way for others who are protecting shorelines, not just here in the Chesapeake Bay, but worldwide. We know this is a problem everywhere. And this is a living shoreline because it's also using a mix of gray and green. While we'd love to see all green, we're getting there. Again, our voices count for all of that. They're backfilling sand, they're putting in SAVs, submerged aquatic vegetation, and also planting on the shore to try to help reduce erosion. And again, this was a $6 million project funded by the REPI Challenge, which is Navy DoD funded and the National Fish and Wildlife Foundation funded. And the project is being administered through the Southern Maryland Resource Conservation and Development Office in Leonardtown, Maryland. You guys heard about that today. So what does all of this mean? Well, ecological restoration and climate resiliency means continued conservation success. Without ecological restoration, with a focus on climate resiliency, the habitat and nesting site of the Diamondback terrapin will be in jeopardy of experiencing extreme loss, which will ultimately affect the population of this already vulnerable species. This site has already seen a loss of over 10 feet of shoreline in the last decade, with a new loss of 4 feet just over the last summer. So again, we're using nature-based solutions. Promoting green infrastructure. It's now actually called blue-green. So we've moved even farther on the scale, and they're adding the ocean part of that. So there's blue-green solutions too. So anytime you hear these coming up, you'll know what those mean. So when? Well, the time is now. Use your voice to promote and protect. Use your skills to assist and uplift. Maybe that's volunteering. Diamondback Terrapin Project. And when you care, others will care. So how can you help? This is just a quick overview of how you can help. I could not put everything on this slide. So think about climate resiliency efforts you can make at home. Again, this is not an exhaustive list. There's internships available, like the ones I mentioned through the Student Conservation Association and all the local educational facilities. You can also support our research, like Dr. Mitchell-Moore mentioned. The QR code here on the bottom will take you directly to the donation site here at UMC's, where if you put in support turtle, terrapin, amphibian research, you will actually be supporting our terrapin project. You can also get involved with local conservation organizations. Again, I listed quite a few. I know there's more. I didn't have room to list everyone, but you can volunteer. Become active in our community, in our environment, see what's happening and see how you can help. And our last page with our acknowledgements. Remember, I said this is a we project. This is our research, and it involves all of these people listed here. The pictures down at the bottom are all the volunteers that have worked with the lab out in the field over the years, and there are dozens more that have worked with the Naval Research Base out in the field as well. So with that, thank you. This is my email if you'd like to get in touch afterwards.